All evidence suggests, and all theoretical understanding of the formation of the moon, helped, by the way, by rocks we brought back by the Apollo program to study and look at, we get a sense of the origin of that place.
We brought back rocks and we were able to
analyze them and realize
origins.
that the moon doesn't have much iron in it.
Okay.
And an object that size should have much more iron in it than it does. So how do you make a whole object that has hardly any iron? So you make it out of a collision with Earth, but it sideswipes Earth after Earth has already sunk its iron to its core.
Right.
So when Earth was molten, heavy stuff falls to the middle, light stuff floats to the top.
Gotcha.
Compared to iron, rocks are light. So all the rocks floated and the iron sunk. Iron, nickel, gold, cadmium, all the heavy elements. They're down there in the core. Okay, so now Earth has pre-sifted the elements. Pre-sifted. Now you have a Mars-sized impactor that sideswipes the Earth, scattering Earth's crust into a ring around the Earth. That Mars-sized impactor keeps going, but the debris mess that it left continues to orbit the Earth. And the slightly larger bits of this have more gravity than the slightly smaller bits, so they'll attract more objects and they get bigger. And as they get bigger, they have even more gravity and they get even bigger and bigger, and it's a runaway exponential growth. The big get bigger and the little ones get
eaten.
Eaten, thank you. Okay. So, we think over not much time, a matter of months, if not only just a few years, Earth had a ring, not unlike Saturn, and that ring coalesced into the moon. And that moon was 20 times closer in the sky than it is today.
Oh, wow. Well, that must have looked beautiful.
Yeah, so imagine that. Just imagine that. It's 20 times wider. Imagine like moonrise. It was like,
yeah, that's very Star Wars, you know? Like, you're standing there in the desert and you see, like, you know, a giant
orb in the sky, and you need music
sky
to go with that, and that would just totally complete the scene.
Yeah.
So it turns out tidal forces are very sensitive to distance. Very sensitive. In other words, not emotionally sensitive, but if you change the distance by a little bit, it'll have a much bigger effect than you'd otherwise think on the strength of the tides. So the moon, the mathematical sensitivity of tidal forces goes as the cube of the distance.
Oh, sweet.
Okay. So in other words, if it just went as the distance, okay, if it was like 20 times closer, then the tides would be like 20 times higher than they are today. But no. Does it go as the distance squared? That would mean the tides would be 20 times 20 higher than today. What's 20 times 20?
Oh, I don't know, 400?
Chuck. Don't you pull out a calculator. You on this show, you're going to tell me what 20 times 20 is.
Let me see, hold on. No, I'm not doing it.
Okay, you got 400. However, tidal forces go as the cube of the distance. So the cube is, you multiply by itself 3 times. So 20 times 20, that's 400, times another 20. So 400 times 20, that gets you 8,000. So the tides, the oceanic tides on Earth, raised by the moon when the moon first formed, were 8,000 times higher than they are today. Tides sloshing on and off the shores, there's friction between the solid Earth and the moving water.
Okay.
And so Earth's rotation back then was actually faster than it is today.
All right.
Depending on how far back you go, you get like an 18, 20-hour day for Earth, not 24 hours.
Look at that.
Okay? So we have a big moon, higher tides, faster rotating Earth. But the tides are so ferocious, Earth is slowing down because of it. And in response, The moon's orbit is increasing. It is spiraling away from the Earth.
Cool.
And it has been doing that ever since. We still have sloshing of tides on the shores. Earth's
Right.
rotation rate is still slowing down. The moon is still spiraling away from the Earth.